All right. Welcome, everybody. How's the conference going so far? Good. How's the energy? Good. Yes. I thought. Yeah. Sorry. So we're here to talk about how do you bootstrap your graph with our dev tools. So as part of that, I'm going to talk a little bit about what our development tools are and how do you get started. The two of us are going to be presenting, so we have a dedicated slide to also mention our third partner who's not here. So I'm Anurag Tandon. I lead our product for user tools, which is a combination of tools that we have for development, but also for analysis. And then, Jun, you want to introduce yourself?
Yeah, I'm Junxiang Chen. I'm the software developer at DevTools.
And our third amigo who's missing here is Greg King, who is the architect behind this presentation, but also our PM for DevTools. So I'll describe a little bit of that. And he thought that vacationing with his family was more important than attending this conference, so he's not here. We'll excuse him for that. The agenda. So we're going to talk about really a couple of things. Like there's as minimal slides as possible. So we'll just explain a little bit about what our dev tools are and what do we mean by them. And then Jun's going to walk through a lovely demo of some data that we found. And that's topical for the UK, but also it's political in nature, which we know and love our US politics. So you can imagine how that might apply to our politics over here. And then just a little bit of a primer on what's the future look like for DevTools.
Quick question.
Yes.
Does this apply both to Aura and on-premise, or one or the other, or both?
It does to both.
Both.
Yes, absolutely. There are some minor differences, but in general, the tools are meant to be, exactly the same. Okay, so what's our mission behind DevTools, right? It's really about your journey as a data practitioner, whether you're a developer or a data scientist. Most of our tools are, I think, coming from our developer legacy and are oriented towards Cypher query language and how do you work with it and how do you get your database going and things of that nature, where we know that data scientists also love some other ecosystems like the Python ecosystem with notebooks and whatnot. But to the extent that they might need our tools, those tools work for developers, data scientists, analysts, and so on. And the idea is we want to help in your journey, right? We want to help you get started if you're new. By show of hands, how many are new to Neo4j? A few? So by Newish. All right. Well, if you want to categorize yourself as new to Neo4j, maybe get some exposure, initial data load, some queries, you're building your skills, or you consider a Neo4j expert. So, again, show of hands, how many new? About 4 or 5? How would?
Maybe a bit more granularity.
A little bit more granularity, okay.
Somewhere in the middle of those two.
Over here, anybody? Okay, cool. And then over here, any? Awesome. Sebastian, you're going to be doing the demo. Come on. All right. So DevTools in context, like what do we mean by DevTools, right? There are 3 tools up here: desktop, data importer, browser. In collection, that's what we refer to as DevTools. There are a few others. There's a GraphQL library that we also sort of think about in the context of DevTools. But we're showing a little bit of our organization to you here in terms of how they're structured inside the company. What desktop is for is to get a local install up and running quickly, being able to manage DBMSs, a database management system, on your local machine, or even some remote machines that you can connect to. But it's a very easy and quick way to get started. Of course, we also have Aura, which is an even easier way to get started because you don't have to install anything at all. But there are some differences between how Aura operates and how desktop operates, and there are some advantages you get with desktop, which is you have full control over your machine and what you can do with it. And you can have the full enterprise capabilities of Neo4j with multi-database and so on. And you can manage memory that you're giving to the instance and so on and so forth. So you can, and you can have access to query logs and because you have control of your machine. So there are a lot of advantages with desktop-based approach, particularly as you get further along in the journey. Data Importer is a product that we have in beta. You heard about it in the keynote. You'll probably hear about it more during the rest of the conference. And we're super excited to have this because particularly for those folks at the newer end of the journey, it is for them to get started easily without having to learn Cypher first. Because what is the first thing you want to do with the database? Well, you want to get your data in there so that you can start working with it. Well, the Data Importer is the best way to get started with that. But it also lets you learn data modeling. And how do I think about a graph? I'm coming from the relational world. I want to adapt my data to the graph world. Where do I get started? So it has a little handy graph modeling area, which June is going to show you. And then on the browser side, that's our tool with the largest tenure, the longest tenure. And it is the tool to really work with Cypher. Learn Cypher, and then have a rich Cypher editing experience for you. So I'm not going to walk through all of the details in this slide in the interest of time. For those of you who have familiarity with Neo4j for some time, this slide is for you. So here are some of the recent highlights of what we have done in this area. Desktop, particularly, we've been doing primarily maintenance. The version 1 of desktop is out there. It does the job. We haven't enhanced it too much because if you've heard of the Neo4j workspace today in the keynote, we have plans around using that inside of desktop in the future, but that's future. So we'll talk about that at some other time. For now, desktop is primarily in maintenance mode. Browser, we've made a few updates in the visualization library, in the speed in which that visualization paints. We use D3 behind the scenes, and we had to do a major bump up to use that. But then also parameters, working with parameters have been made much easier inside of browser. So if you have worked with parameters or if you're learning about parameters, check out some of the advancements there. Some capabilities around graph visualization, zooming, being able to zoom to fit, or just scroll and zooming in and out, which was something that is requested for a long, long time. Also, what's not mentioned here, which we'll show, is a new properties panel, or relatively new. It's been there for some time, which makes it easy, very, very easy to inspect the properties on a node or a relationship. And then we've also centralized browser hosting inside of Aura, where browser is available on browser.neo4j.io. And then you can connect that browser to any database. Prior to that, our Aura instances were, like Neo4j always comes bundled with browser, and has been. And so for people who just use that package in the bundle and then deploy browser and then use browser that's inside that bundle, well, you're stuck on the version of browser that was there at the time. And we have a much more rapid development cycle for these tools than the database does. Or your propensity to upgrade the database is maybe not as much as the tools themselves. So by centrally hosting browser, we make the latest and greatest available to you right away, and then you can use it with any database, whether that's in Aura or whether that's on your self-managed environment. And then Data Importer is a new thing. And then we've made some enhancements to that. Particularly in Aura is where we started with Data Importer, and it's available in the AuraDB and in the AuraDS self-serve tiers, so free tier or professional tier or self-start tier, and we'll be rolling it out to enterprise at some point. So that's about it, and with that, I'm going to turn it over to Joe.
So good afternoon, everyone. I'm going to walk you through a graph project by leveraging Neo4j DevTools. The data set we are going to look at today is from the UK Parliament. Parliamentary system plays an important role in the United Kingdom's democracy. It has two health systems, health of Commons and House of Lords, their work is similar. People are elected as members, or we call MPs, to sit in the House. They are able to debate and vote for certain divisions, which will be further rolled out to be policies, laws, bills, etc. And those members represent certain region of the country, which we call constituencies, and they sit in either of the house. They are also responsible for scrutinizing the government, and typically one decision made in one house should be approved by the other. And the UK Parliament open sourced the data in their official website to ensure the transparency, also reviews members' political activities, how they vote, and how it's related to their parties. And there is a community project called Public Whip. It collects and rearranges data to a more structural way, so that this data is more machine readable and consumable. The data we downloaded is from the Public Whip, which the sample data is shown in the right-hand side. They are mostly arranged in the relational database, which we called tables. We converted each table as a CSV file. Also, there is a JSON file as well. So let's look at the sample data here. So the table on the top here shows the people's metadata. For example, the member, Mrs. Diane Abbott, she belongs to the Labour Party, and she represents Hackney North and Stoke Newington constituency. She sits in the House of Commons. And the table in the middle with the dark pink color, which shows the division. And the table on the right-hand side here will shows how the member is voting for the specific division. So Mrs. Abbott, this lady, maybe you know her, she's really famous in the UK. And she voted no for this referendum bill. And this bill is related to the blue table over there, which is the policy called Pro-EU One Nation Conservative. So based on this sample data, let's find out how these members vote for the issues you care about. You may notice these tables are drawn in different colors. That means I'm going to construct different graph entities respectively later on. So we can, so in the relational database thinking, you may know each table has the primary key, which identifies each row as unique, and it has index, and it has foreign keys to link the table together. So we can sketch out our graph schema like that. So basically, the person held the office, and the person can be elected as a member to sit in the house, and the member is representing for the constituency. And the member belongs to a certain party, and the member is able to vote for a certain division, and the division finds support to the future policy, and the policy is the subset of the policy set. And here is a wiki edit. This is a community project, so the wiki edit is a kind of thing like contains the details of the division metadata. So based on the data we collected, we are able to load those CSV file data to the data importer. In the interest of time, I'm just going to show you this part of the data import, because the whole data set is massive. It takes a lot of time to load. So let's launch data importer. So in data importer here, the canvas in the middle is the place you can sketch your graph model. Let's start with sketching. We can add one node from here and drag out with an associated node and relationship. And by double-clicking that, we can start adding the caption, person, member, with the relationship called elected. Now we have a nice graph model like that with dashed outlines. Now we are going to import the data. Just simply drag this file to the file panel. And in the file panel here, it visualizes all the columns in the CSV file and the sample data in the first row of the CSV file, so that you know what's the file is about. By selecting one node, you can start mapping your data, which input field is populated on the right-hand side. So in here, we selected the file we already imported, and we can add a property on the node. And each property has to be mapped to a certain column in the file. Alternatively, you can use Add from File button here. You can just add the properties, add columns as property. And those properties will be populated in the property panel, and those property names are exactly as the same as the column name, but you can further edit those property names and give them the correct data type. After you edit the properties, you have to specify the key, which we call unique identifier for the node. So we specify person here, and once we finish the mapping here, as you can see, the node over there transform from the dashed outline to solid line. That means the node mapping is finished, and you are ready to go to upload your data to the data importer. Same way, we can quickly map the member node as there. So once we finish the column mapping, you can see some green dots populated on the left-hand side. That means some columns are already mapped into the graph model somewhere. So we are going to map the relationship. And the relationship mapping is a little bit different kind of thinking with the relational database. So the relationship, some people might think the relationship is more like the foreign key in the relational database, which refers one to another. But actually, it's more like something in the middle. It takes the primary key from both tables as its unique identifier and link two tables together.
In this way, like the graph database is slightly different from relational, because in graph databases, you are persisting those relationships, while in the case of relational, usually those relationships are sort of embedded in the record. And it's something that the domain specialist knows about, but not necessarily something that the database actually has.
So is that radically different from the kind of many-to-many resolution where you put in a linker table which would have primary key? Is that similar?
And that's very similar, right? That table has to be specially constructed in a relational environment to have that, where you can persist it here in the graph database.
Yeah, once we finish the mapping, we can start the run import. So basically, we can add the database link and specify the database credentials. So actually, we have the database running in local here in Neo4j desktop. And we specify the password, start running the import.
Does it have to be an empty database? Is it creating or merging onto it?
It will do the merge, so you can do this multiple times.
Yeah.
You see the merge happening here.
So that's why you need a unique identifier for the node, so that it won't create a duplicated record in your database to mess up your database. So
there are actually a couple of things that this does, which is following more best practices of graphs. One is the creation of these constraints, which not only specifies the ID for your node, but also then makes, behind the scenes creates an index and makes for faster data loading to happen.
And if the record already exists, does it ignore it or it updates it?
It updates it.
Yeah, so how database work, how data importer work under the hood here is that it reads the file stream and it generates a Cipher query and takes the data read from the the data stream to embed with the Cypher query and take it to the database. So we took 4 seconds and load around like 10,000 nodes and 7,000 relationships in the database. And in this button, we click here, it redirects you to the Neo4j browser, and it will give you the first 25. It will give you the first 25 results. But seems like the internet is not that good, but I can show you what it will look like. So if you click this button, it will take you to the Neo4j browser and with the query, so that you can query for the result like this. So we can continue mapping and upload, continue sketching and map the data via the data importer, and the final data model will look like this. And some of the nodes and relationships are coming from exactly the same file, and some which we call one denormalized file, and some of them can come from different kind of data source. So yeah, so data importer has the flexibility for you to map the data you want. And we wish data importer can take you all the way to the data sketching, graph model sketching and mapping process. However, in this case, it's only able to load 90% of the data set we want. As you may notice, there are some dashed outline over the graph model. That means that indicates some areas in the graph model we are unable to map the data via the data importer in the current version due to the limitation of the scope, but for a number of different reasons.
Yeah, so there are many different things. The data importer is a beta product right now, so we focused on the most valuable use cases at the moment. And so there are quite a few scenarios of modeling which are currently not supported, multi-key nexus being one, multiple labels on a node being another, and there are a few others that are mentioned here. But the good news is that those things can be modeled in Neo4j. It's not a Neo4j limitation, it's more of a data importer limitation at the moment, but we do have Cypher solutions, Cypher-based solutions for these other things, which you can run in browser, you can run through other means. And so, yeah, we're just kind of scratching the surface for data importing.
Can you do the multiple labels with a second file, or no, you just run into the update issue?
Correct.
Okay,
Yeah.
it just changed the label?
It just supports one label per node.
Gotcha.
Yeah.
Yep, we're elaborating to enhance the feature so that it will give you the more seamless user experience in the future. So suppose we already load all the data to the database, and actually we already prepared for the data in our database, and we already launched the Neo4j browser. So let's switch to the database that contains all the data we want, and then we can start querying for some interesting data for that. But firstly,
You can see, for those of you who are not familiar with browser, you can see how many nodes and how many relationship types exist in the database at the moment. So it's about 53,000 nodes and
4 million relationships. So we can run this query called DB schema visualization to visualize the current database schema. So it's exactly what we have shown in the previous slide. And in this property panel, you are able to just adjust its size, and you can use the zoom in, zoom out features to adjust your visualization or zoom to fit. So let's start finding some certain interesting topics and associated relationship path. Let's choose Brexit, which is the topic that polarized the country. Let's find some policies that are associated to Brexit.
June is typing, you can see some of the auto-completion of Untitled Browser showing up. Again, for those of you who are not familiar with browser. We want to do more with auto-completion, and not yet satisfied with where it's at, but we can see a few of the helping features that are already there.
Yep, let's query for Brexit with
Does
case.
that overlap with Bloom? And are you going to continue to have two products, or will one overtake the other?
I don't think that overtaking is the right way to think about it. Like this.
Will they converge?
The two products are meant to be associated with different personas. So this is more of a Cypher query editing tool where you work with Cypher primarily, and then you visualize data through tables or graphs and things like that. But Bloom is more of a search and exploration, point and click type of tool for endless personas.
Right.
And so we can see imagine a future where the inputs could be search or Cypher queries, where the outputs could be, again, common between the two. But with the evolution of workspace, that is something that we need to think about.
Gotcha.
Because we are trying to bring these things together, and that provides the opportunity to build more unified experiences.
Yeah, so we got the query result. So we search for the keyword Brexit with case insensitive here, and we also return the number of connections on the policy node as the degree, so we can see how many divisions or something connected to this policy. So looks like there are 3. So we can randomly choose this one to see how people express their positions around this policy. But I'm not going to type all the queries over there, so we prepared for the queries we are going to run through in this session. So here is the fail rate panel that you can save your commonly used Cypher query over there. So the second query we are going to look at is that we query for the path from the person to member, from member to division, and from division to the policy, and the policy name contains closer alignment with EU post-Brexit. So let's run this query, and we can see it returns one relationship path over there. And some nodes don't have the caption, but in the property panel here, you can specify what property can be shown as the caption in the graph. Yeah. So in the property panel over there, you can also check the property details one by one. And for the loan property over there, you can also click show all to review all the loan properties. And at the bottom here, you can click and just copy the value to your clipboard and paste anywhere. So in this one, this member in the parliament voted yes, or effectively A, for this European Union withdrawal division, which finally support the closer alignment with the EU post-Brexit. And
Are you limited, or is there only one person who did it?
yeah, we have the limit 1. Yeah. So further away, we can start with more general data inspired by this Cypher query. We can remove the condition over there and return a more general data. For example, here, Mrs. Abbott, she was elected as the member, and she voted no for hunting bill, blah, blah, blah. And this division support Boris Johnson as the prime minister. So basically, she has the position against the policy that Boris Johnson to be the prime minister. And similarly, we can also query for some people has the position for some policy. So we have the condition, we have the query with the condition over there to query for one item with some people one person has the position for one policy. So here there is a member called Campbell. He or she was elected, and this member voted no for Iraq war, which doesn't support the Iraq war against the vital vote. That means this person, because these two paths has the same value, that means this person has the full position for this policy. So we query for these two examples, and they are quite informative to show how people express their political positions with the policy. But obviously, this is not intuitive because the value was embedded inside of the property.
Yeah, so you can always, what you can do with any of these things that are frequently analyzed, or paths that are frequently analyzed which are based on property values, what you can start doing with graphs is enrich that with more meaning, right? And so what you can do is, if you go for the next builds, that you could put actually relationships between that originating node and the ending node to be able to quickly find these nodes without having to type in large, long queries, right? And so that's the advantage of graphing. You have to create a new table, you can just embed another relationship and then traverse the path very easily.
Yeah, so we are going to create a shortcut relationships that between people and policies so that we can easily find out people's positions with the associated policy. So we can quickly do that. Understand that each line of the query is not important in this session because there's a lot of things to take in. But in summary, we are adapting the query we wrote before, and we have the create statement to create a shortcut path with position 4. Let's do that. So around 5 seconds, it creates 42,000 relationships. And as you can see here, the position 4 relationship is populated over there. And I have drawn the color with green, and we can quickly click that. It will give you another cipher query on the result frame. So here we can enter the full screen mode and view the graph in the detail. So Mrs. Abbott, she has position 4 for those different policies. So similarly, we can adapt another query for...
And another advantage of having this kind of shortcut relationship is that now you don't have to visualize those intermediate nodes, because otherwise you would have to see a graph and then try to find, where the beginning and the ending node is. Now with doing it this way, you can, get a much more consumable visualization.
Yep. So, we can change the color of the relationship by using the property panel. And similarly, we can adapt another query for building position against relationship. So it roughly take 6 seconds for building 43,000 relationships. And also this one already populated over there. We can start querying that. And enter the full screen mode. Also that Mrs. Abbott, she has the position against those different policies. And in the settings here, if we tick connect result nodes over there, and if we rerun this query in the result frame, it will give you the associated, we only query for position against, but in the result, you can also see the position 4 relationship. It's because if you tick this option on, that will also return the neighborhood relationship and the neighborhood nodes for the query for you. And interestingly, one person can express position for and position against toward the same policy. That's probably because there are many divisions they voted for, and they voted probably sometimes for, sometimes against. We also embed the number of votes in the relationship in the previous query. So you can see the Mrs. Abbott has the position for this policy for 24 times and position against this policy for 12 times. Now we have a really good relationship between person and policy, so we can check this in the individual level. But how about do it aggregating this data in the party level, so we can check how people vote, express their positions in the party, and how polarizing one party is, and what policies divided the parties. So here we wanna summarize for and against votes for in the party level, so we can further adapt some queries like here. So here we just restrict our data to be in House of Commons, and we power up the we statement to aggregate the data from the individual level to the party level, and we return those data we want. So let's run this query. So it gives you the tabular format data. This is how graph database and Neo4j Browser is useful. It's not only always return you the graph, it can also give you the tabular format. So let's look into the detail of the data set I grabbed here. So there are two different policies. One is called Iraq 2003 for the invasion. And both Labour Party and the Conservative parties have the overall position for this policy. And as you can see, the number of people who voted for is significantly larger than position against. And alternatively, by contrast, there's another policy called homosexuality equal rights. So overall, the Labour Party expressed the position for this policy, but the Conservative Party has the position against. But as you can see, these numbers of people are quite similar. That means this is more controversial or polarizing inside of the party.
There's only 600 members of parliament, or 600 and something. So
this is a person. Yeah, this is a person was elected as a member. So we are looking at the person level with the party level. So this is more. The number is more than the parliament because some people are not in the parliament. So yeah, based on that, how can we just pivot the data to reveal more useful information? For example, we can probably work out the polarization score that shows how polarized the party is on the specific topic. So we can adapt these two expressions. For example, we can work out the proposition for variable, which calculates the overall proposition for people who voted for against the whole number. So if the value is greater than 0.55, that means the party is for this policy. And if this is less than the 0.5, that means the party is overall against. If it's equal to 0.5, that means it's like equally divided. And if the value is closer to 0.5, that means this policy is more polarized. But if the value is distributed near 0 and 1, that means the party is more aligned. So we can normalize this proportion for variable by using this expression to normalize the data from the range 0 to 1. So basically, if the value is closer to 0, that means the party is more aligned. And if the value is closer to 1, we can say this party is more completely polarized. So we can adapt this this query in the browser. So this is a really long query, and we are going to show you is that how we can edit the long query in the Neo4j browser. So we can use the escape key to enter the full screen, and you can use a couple of different keyboard shortcuts, like the command with bracket to sort out the indentation, and you can also use option up and down to move the line up and down. And you can also use Command Shift L. For example, here, Command Shift L, we can just rename the same pattern over there if you are not happy with that. And also you can use Command F to find the specific pattern and do the replace in your Cypher query. And let's quickly run this Cypher query. And this is what we really want to get, as the slide shows.
Under the covers of the editor, you keep going. Under the covers, we have the Monaco editor that is being used inside of browser, which is also the editor that's used inside of VS Code. And so a lot of the shortcuts that Jun was mentioning were all part of the standard set of keys that you get.
Would it be possible to do something like a beautify option where you just select it and it works out the indentation?
Does that exist?
Sorry?
Like a beautify option, does that exist?
Not yet,
Okay.
but we plan to do with the language server we are implementing on the market.
Yeah.
Yep, cool. So finally, we can build the relationship in the party level. So previously, we built the relationship between person and the policy. We can also build the relationship called party alignment on policy with the number their overall position and the polarization score. So here we can. So here we can quickly just create a relationship, and then we can just quickly comment this line and uncomment this line to create the relationship. And the relationship party alignment on policies populated here. And finally, we can use our sister product Bloom to visualize the data we want. So let's query for this relationship, and it shows parties' position on the policy. And we can just add the filter. We can just focus on two biggest parties in the UK Parliament, Conservative Party and the Labour Party, and apply filter, dismiss the rest. And then we can just show the two parties' political positions on different kind of policies. And we also use the conditional parameterized styling that we draw the position for with green color and the position against with the red color.
The presentation button.
This.
Second, yep.
Yeah. Yeah. So yeah, we have the visualization like this. And if the parties, based on the polarization score, if the score is higher, that means it's more polarized. If the score is lower, that means the party is more aligned. So if the relationship line is thicker, we set the rule is like this, the polarization score is less. So if the line is thinner over there, that means even the party has the position with some policy, but it's more polarized. And as we can see from here, those two parties are almost against, disagree everything. And but one thing they strongly agree here is called in favor mass civilians. Yep. So this is the demo of our use of dev tools let's head over to Anurag.
Oh, cool. So this is just to kind of wrap up. We're running out of time, I think. In terms of key takeaways, multiple tools available to you, and each different tool has different purposes, but together they should be helping in the development journey, and that's what we're all about. In terms of future roadmap, so the one thing that I want to take, there's lots of things to talk about, but the one thing I want to leave you with is the idea of this, the workspace that Philip talked about earlier today, and Michael tried to show you. And then we also have another session tomorrow. Ian's going to be leading it tomorrow at 1:45. So please go watch that session for more detail on the workspace. But that's our idea, to kind of bring these tools together and provide a unified experience for all of you as data practitioners, developers, data scientists, what have you. And I think that's there's the material that we used today. If you want to play with it, that's available at this link. I'll leave the QR code up here if you want to take a picture or anything like that. But it's very simple, dev.neo4j.com/devtools, and you should get that there. Some of our credits here. Anybody else need to take a picture? Okay. And I think that's it. We will stick around for any questions, but we will leave the podium for the next presenter. So I think with that, thank you so much for joining the session.